there, I hope you're keeping super well and are in the best of your spirits. Well, as you would have already read, we are here today to discuss and examine thoroughly the question paper of JEE Main 2020 exam, which was conducted on 7th January in the morning from 9:30 to 12:30. Well, before we actually dive into the insights of the paper and begin analyzing it, please note that this is a memory-based discussion of the paper and therefore this might vary from the actual paper. Okay? So I'll begin with distributing the entire syllabus among 4 units: algebra, coordinate geometry, calculus, and the remaining miscellaneous chapters. Beginning with algebra, these are the following chapters. Firstly, we had one question from complex numbers, pretty high on arithmetic. Next, we had a standard single question from quadratic equations. PNC, again, one basic question. Sequence and series, we had 2 questions from here, one from AP and one from GP. Binomial theorem, well, there was a bit difficult question from here based upon coefficients. Then we had 2 questions from matrices and determinants, one on multiplication of matrices, the other from system of equations. Then the entire chunk of trigonometry, well, there was a single question from here from solutions of triangle, that too based upon centers of a triangle. So all in all, there were 9 questions from algebra. I would say the section was really easy, but yes, because there were some analytical calculations involved and solving was involved, yes, the paper in this section was lengthy. Next, we have the section of coordinate geometry. Absolutely no direct question from straight lines and circles in the paper this time. But yes, there were 2 questions from conic section, one from ellipse, other from parabola, completely based on basic standard results. Next, we had 3D geometry, one question based upon the image of a point about a plane. And lastly, we had a bit difficult question from vectors based upon angle bisectors. So all in all, there were 4 questions from this section. This was an above moderate section, and yes, a lot of memory was tested in here. A lot of callbacks were required of the different formulas and the equations to tackle the questions in this section. Next, we have this section of calculus. So one question was asked from sets, relations, and functions based upon composition of functions. Next, we had 1 question from limits, which was pretty high on arithmetic. Then we had 3 questions from the topic of differentiation, out of which 1 was yes on a difficult end based upon the points of non-differentiability concept. Further, next we had application of derivatives, 1 question from here, yes on a difficult end. Again, the topic was Lagrange mean value theorem on which it was based. Next, we had definite integration, 1 question based upon King's rule. Area under curves had 1 question, and standard 1 question from differential equations. That's how we had all in all 9 questions from calculus. The paper was conceptual from this part, but yes, on a lengthier end, and I would rate it as a moderate to difficult section. Let's move to these miscellaneous chapters. So statistics, we had 1 question based upon variance. Next, probability, again 1 question from probability distribution. And lastly, 1 short as expected question from mathematical reasoning from logical equivalence. So this entirely completes our detailed distribution among these 4 units. Now let's focus on the change in pattern which happened for the first time this year. As observed, the 5 newly introduced questions which were numerical based were pretty high on arithmetic and yes, were lengthy. Now let's talk about the difficulty level of the paper and the distribution between 11th and 12th standard. If I move towards the ratio of easy, medium and hard, it was approximately 1:2:1, which means that the paper was nicely set and well structured. Next, as you can see that the number of questions asked from 11th and 12th were almost the same, so the weightage was approximately equal. All in all, we can say that the paper was well structured and well balanced. Okay, so this question coming from area under curves is asking you to find the area which is enclosed within the circle x square plus y square equals 2, which is not common to the region which is bounded by the parabola y square equals x and the straight line y equals x. So all these 3 figures that you can see are very, very simple to draw, first of all, right? So once I have the figure ready, understand what is supposed to be found. So the region which is bounded by the parabola and the straight line is this colored region. Okay, this is the region which is common to the area enclosed within the circle as well. So first of all, we are going to find the area of this colored region. Then from the area which is enclosed within the circle, I will be removing this area to get my required area. So let's begin. For that, firstly, we have to decode that this point P that you can locate in here, which is the point of intersection of all these three equations given to you, is having coordinates 1, 1. It's very simple for you to find out. That means this point is 1, so I can find the area of this colored region using horizontal strips, right? So it's very simple. I'm going to integrate from 0 to 1. Area under the straight line, that means x equals y, minus area under the parabola, x equals y square, with respect to y. Right? So this becomes y squared by 2 minus y cubed by 3. The limits are from 0 to 1. Very easily you get 1 by 2 minus 1 by 3, which gives you a 1 by 6. This is the area of this colored region. Now, area of the circle. Circle is x square plus y square equals 2. That means x square plus y square equals root 2 square, which gives you the radius of the circle to be root 2. So the area of the region enclosed within the circle is what? Pi into radius square, that is pi r square. Your radius is root 2, so pi into root 2 square simply gives you a 2 pi. So from 2 pi, that means from the area which is enclosed within the circle, that is 2 pi, you remove the area of this colored region, that is 1 by 6, you get your required area. So your answer is 2 pi minus 1 by 6 square units to be the area of the circle, or to be the area of the region enclosed within the circle, which is not common to the area which is enclosed by the parabola and the straight line. Got it? Your answer is 2 pi minus 1 by 6. Now in here we have this next question from functions, which is from the concept of composition of functions. So let's see what the question says. It gives you g of x equals to a standard quadratic function, that is x square plus x minus 1. Further, it gives you g(f) of x as 4x square minus 10x plus 5. The question is asking you to find the value of f of 5 by 4. Now realize in here, there's a simple catch. When g is applied to some input x, the answer is x square plus x minus 1. So g(f) of x is nothing but g of f of x, isn't it? That means now the input is f of x. So g of the input f of x, according to this definition, will be f of x whole square plus f of x minus 1. And from here you get this equation, right? Now obviously we are interested in f of 5 by 4. That means the signaling is towards taking x equals 5 by 4. When I do that, the equation becomes f of 5 by 4 whole square plus f of 5 by 4 minus 1 equals 4 into 5 by 4 whole square minus 10 into 5 by 4 plus 5. Obviously, for convenience, let's just take f of 5 by 4 equal to t, just for convenience. So my equation becomes t square plus t minus 1 equals that right hand side. Okay. And now it's pretty simple. You just need to solve this analytic equation accurately to get a pretty looking quadratic equation. So when you do that, you get t square plus t equals minus 1 by 4, which in the next step gives you 4t squared plus 4t plus 1 equals 0. And this is straight away what? This is 2t plus 1 whole square. From here, you know the next step, t is minus half, but don't forget t was nothing but f of 5 by 4, and that is what you wanted to find. So your answer is minus 1 by 2. Okay, coming from the world of differential equations, we have this question, which is giving you a full-fledged, good-looking differential equation and is saying that y equals y of x is a solution of this, such that at the point 0, at the point x equals 0, y of 0 is 0. we have to find out what is y of 1. That means when you plug in x equals 1, what is y of x? It means y of 1 equal to. So of course the question is all about solving this differential equation, and for that, first of all, right at the first glance, what do you infer? We'll try to simplify this first of all. Okay, we'll first try to simplify this by keeping dy by dx one side and everything else on the other side. So it's very evident. What I'm going to do is, here, I'm going to write it as dy by dx minus 1 equals e to the power x upon e to the power y, which makes it what? Dy by dx minus 1 equals e to the power x minus y. And in the next step, obviously, we have dy by dx equals e to the power x minus y plus 1. So you've simplified your differential equation, and one thing which you can catch hold of is that the variable part in here, which is this, is a linear function in x and y. In such cases, what do? How do we tackle such differential equations? In such cases, we plug out this variable part, that is x minus y, and substitute it to be equal to another variable, that's t. And then from there, we try to find out dy by dx's value in terms of dt by dx. So let's do that. You know the drill already. I substitute x minus y equals t, differentiate both sides with respect to x. I get 1 minus dy by dx equals dt by dx. And straight away in the next step, I write that from here, dy by dx is equal to 1 minus dt by dx. Right. So now, in place of dy by dx in the first equation, we substitute 1 minus dt by dx, and that transforms my equation into 1 minus dt by dx equals e to the power, not x minus y, but now e to the power t plus 1. Cancel out the ones from both sides, and your equation now is dt by e to the power t with a minus sign equals dx. Yes. That's where your variable separable part comes into picture, because this was reducible into variable separable form, as you can see here. So I can write this as minus of e to the power minus t dt equals dx. When you integrate both sides, what do you get? You get minus, as it is, e to the power minus t into minus 1 equals x plus your constant of integration, which gives you e to the power minus t equals x plus c, and right at the end, of course, you substitute t equals x minus y, and therefore minus t comes out to be equal to y minus x, and your solution is this: e to the power y minus x equals x plus c. Now, of course, you know the initial value problems in such picture. What do you have? You have y of 0 equals 0. That means when you plug in x equals 0, you get y equals 0. So let's do that. Plug in x equals 0, you get y equals 0. This makes this equation give you what? Well, let's see. You get e to the power 0 minus 0, that is nothing but e to the power 0, that is 1, equals x is 0 plus c, and therefore your c from here is 1. Okay. The moment your c is 1, your solution now is this. Right? We have to find out y of 1. Now, in this equation, let's plug in x equals 1 and correspondingly find the value of y. That's what is the question. So my equation is going to give me what? E to the power y minus 1 equals 1 plus 1, that's 2. Right? So from here I can write y minus 1 equals ln 2, or y equals 1 plus ln 2. Well, coming up from the chapter conic sections, under the topic of parabola, we have this question which says that if y equals mx plus 4 is a tangent to the parabola y square equals 4x and the parabola x square equals 2by, then using this, find the value of this unknown b. Now, first of all, it's very straightforward, direct approach that if I have the parabola of the form y square equals 4ax, then the equation of the tangent to such a parabola of slope m is given by y equals mx plus a by m. So in here we have the equation of the parabola as y square equals 4x, that means your a is 1. So the equation of any tangent of slope m to this parabola will be given by y equals mx plus 1 by m, right? Where m is the slope of the tangent. But wait a second, you are already given the equation of the tangent as y equals mx plus 4. So both these equations are representing the equation of the same line. Of course, when you compare them, what do you get? It's It's very simple. Compare this and this. Straight away you get 1 by m equals 4, or your m is 1 by 4. So you understand that the tangent which the question is talking about has slope 1 by 4. And the moment we've got m equals 1 by 4, I can explicitly get the very equation of tangent to this parabola as y equals what? Y equals 1 by 4 times x plus 4. Right? Because m is decoded. So this gives me the actual equation of the tangent as y equals x by 4 plus 4. Wait a second. The same line is a tangent to another parabola x square equals 2by. Now when a line whose equation is known to you is a tangent to a parabola whose equation is also known to you, you have two equations in picture, right? And here when I use the condition of tangency, what does it actually give me? It gives me that when I solve both these equations, what I'm going to get is a quadratic equation which is going to have what? A single solution in a distinct form. That means its discriminant is going to be 0. What I'm trying to say is that this line is a tangent to this particular curve. Let's solve both these equations simultaneously. What do you get? Well, you get x square equals 2b, and y, in place of y, I'm going to plug in x by 4 plus 4. When you solve this, what you get is a quadratic equation in x, which is nothing but 2x square minus bx minus 16b equals 0. Right. Now, this quadratic equation has its roots as the values of x. Now, if this line is a tangent to this parabola, obviously there is only one distinct value of x which you're going to get as a solution of this quadratic equation, and that can only happen when the discriminant of this quadratic equation is 0. So that happens to be the condition of your tangency. I'm sure you would be able to recall that. And therefore, from here, what can I say is that discriminant of this quadratic equation is 0. That means b square minus 4 into 2 into minus 16b. That gives you a plus 128b in here. Basically, this is 0. So from here you get b to be 0 or b to be minus 128. Now b can't be 0, obviously, right? Because the equation of the parabola is x square equals 2by. So b better be non-zero, and therefore you declare that b is nothing but minus 128. Got it? That's what you had to find. You've got the answer as b equals minus 128. Okay, let's take a look at this question. Now in here you are given that alpha and beta are two real roots of this quadratic equation. Now this equation, as you can see, involves two unknowns, k and lambda. The question says k and lambda are real numbers, and specifically k is not equal to 1. If tan square of alpha plus beta is equal to 50, what is the value of lambda? Now first of all, realize what we have to find and what is given to us. We have to find out lambda, okay. Tan square of alpha plus beta is given as 50. Now, if tan square of alpha plus beta is 50, that means tan of alpha plus beta whole square is given to me as 50. And of course, I recall the identity tan of a plus b is equal to tan a plus tan b upon 1 minus tan a tan b. This in the next step gives me tan alpha plus tan beta upon 1 minus tan alpha into tan beta whole square is 50. Right. Okay, so this somewhere consists of tan alpha and tan beta, and the information about alpha and beta is that they are real roots of this quadratic equation. Let's just take a look at this quadratic equation. It says k plus 1 times tan x whole square minus root 2 lambda times tan x equals 1 minus k. So of course, one thing which is a big time catch in here is to realize that this is a quadratic equation in tan x, isn't it? I can write this as k plus 1 times tan x whole square plus minus root 2 lambda times tan x minus of 1 minus k, right, equals 0. Okay. The moment I understand that this is a quadratic equation in tan x, alpha and beta being its roots means tan alpha and tan beta are actually the values which are making or satisfying this entire quadratic equation. So I have tan alpha and tan beta to be the roots of this quadratic equation. The moment I have that, I recall the relationship between the zeros and the coefficients of a quadratic equation, and that gives me sum of the roots and product of the roots. So sum is going to be tan alpha plus tan beta, which is minus of coefficient of tan x upon coefficient of tan square x. That is going to give me root 2 lambda upon k plus 1. And what about tan alpha into tan beta, which is product of the roots? It is constant term upon coefficient of tan square x. Constant term is minus of 1 minus k, that is k minus 1, upon coefficient of tan square x, that is k plus 1. The moment you have the values of tan alpha plus tan beta and tan alpha into tan beta, let's just plug it in here in this equation. What do you get? You get root 2 lambda upon k plus 1 whole upon 1 minus of k minus 1 upon k plus 1. All of this whole square equals 50. Okay, of course there will be cancellations, and on the left hand side you are going to get an expression which is free from k. It's a very simple calculation. And what you get in here is root 2 lambda by 2 whole square equals 50. And that in the next step gives you 2 lambda square by 4 is 50, or 2 lambda square is 200. Right? This gives you lambda square equals 100, and lambda is therefore plus minus 10. The option doesn't have a minus 10, and therefore I'm going to accept the answer in here as lambda equals plus 10. Got it? Coming up next, we have this question from the chapter conic sections from the concept of ellipse. So the question says that the difference between the two foci of a standard ellipse is 6, right? And the distance between the two directrices is nothing but 12. Based upon this information, we have to find out the length of its lattice rectum. So if I consider the ellipse's equation to be the standard one, x square by a square plus y square by b square equals 1, that's how it looks like. So the coordinates of the foci are nothing but AE, 0 and minus AE, 0. The distance between the two foci is 6. That means AE plus AE, that is twice of AE, is 6, which straight away gives you AE to be equal to 3. Right? Okay, next thing is that the two directrices in here have the equation x equals a by e and x equals minus a by e. So the distance between them is nothing but a by e plus a by e, that is twice of a by e. This is given to you as 12. So you get from here a by e equals 6, right? From here you get a by e equals 6. So you can see two things. AE is 3 and a by e is 6. Based upon this, we have to find out the length of this lattice rectum. And you know the length is given by twice of b square by a. This length can be known only when we have the explicit value of a and b square known to us. Now somehow, this is very, very simple for you to realize. It's a basic question that when I solve these two equations simultaneously, I'm going to get the value of a, realizing that e is a positive quantity. So how do I solve these two equations simultaneously? It's very simple. Well, you can relate them in many ways. You can from one equation find out the value of a, plug it in the other, or basically find out the value of e and plug it in the other to get the value of a. Or what you can do is realize that ae multiplied by a by e is going to lead to cancellation of e's. So let's use that. AE into a by e simply gives you 3 into 6, that's 18. EE gets cancelled, it's always a positive quantity, giving you a square equals 18. Right. Now a square is known to us, a therefore is nothing but positive square root of 18. Still b square is left to be known. How do I find out b square? Well, what is that relation which relates b square with the quantity a or a square? It's very simple. It's standard thing that you would definitely be remembering. We know that in such an ellipse, c square is a square minus b square, where c is given by a into e. So c square is a square into e square. Now ae is given as 3, so a square e square is nothing but 9. This 9 is equal to a square minus b square. A square is 18, so you get this equation with just a b square unknown. When you solve this, you get b square equals 18 minus 9, that is 9, and bingo, you have your b square with you. So you can see here you have a known, that is root 18, you have b square known, that is 9. Just plug it in here and you will get the length of the lattice rectum. So this is 2 into 9, because your b square is 9, divided by a, that is root 18. So this gives you 2 into 9 by 3 root 2, right? So 3 into 3 gives you 18. What do you get is again a 3 root 2. So 3 root 2 is your answer, which is the value of length of lattice rectum for this particular ellipse. Coming up next, we have this question from Mathematical Reasoning, which is a chapter from where a question in JEE Main is a must-have. The question here is a pretty easy one. It gives you a statement and asks you what is it logically equivalent to out of the given ones in the options. So if you take a glance at the statement given to you carefully, it involves the implication sign. And whenever we have implication sign in the statement, we always follow the strategy of making a truth table to answer such questions. So if I go by that approach, it's going to be pretty simple again, because I'm going to make a column with P's truth values and then similarly Q's truth values. And then I'm going to make another column for P implies Q's truth values, and then the truth values of Q implies not P. Fine. And if I take this as 1 and this as 2, I want to find out 1 and 2. This statement's truth values basically. So 1 and 2 come out to be the statement with these truth values, and if you can carefully see from this truth table, all these truth values are coinciding with the truth values of negation P statement. And therefore, from this truth table concept, I conclude that this statement which is given in the question, which I have expressed it as 1 and 2, is logically equivalent to negation of P, and accordingly you can mark the correct answer in here. Okay, then, belonging to the umbrella of algebra, comes up the next question from Matrices. It says, if you have this homogeneous system of 3 equations consisting of A, B and C constants, as you can see in here, such that these A, B, C are all real numbers, they are all non-zero, they are all distinct, then if this system has a non-zero solution, find out the relationship between these constants A, B and C. Now just recall the concept. A homogeneous system of linear equations either has a unique solution, which is your trivial solution, or it has infinitely many solutions. So here if the question says this system has a non-zero solution, that means this has a non-trivial solution, which is only possible when the coefficient matrix that you have in here has its determinant equal to 0. So obviously in here also the same thing is going to happen, and that is where the question begins from. So we take the determinant of this coefficient matrix to be equal to 0, and obviously the first step is to simplify this to get a relationship involving A, B and C. So here you see the first column is completely consisting of 2, so obvious operation is row 2 goes to row 2 minus row 1 and row 3 goes to row 3 minus row 1. When you perform both these operations, you get this as your resultant determinant. Now obviously your entire first column is consisting of 2 zeros are created, so you expand this determinant with respect to the first column. What you get is 2 multiplied by 3b minus 2a into c minus a minus b minus a into 4c minus 2a, all of this equal to 0. Now obviously now on the question is all about simplifying, solving, analytic calculation. So you just have to be very accurate, otherwise it's very simple. So when you solve this, you simplify this, some terms get cancelled out, and what you're left with is this relation involving A, B and C, that is minus BC plus 2AC minus AB equals 0. You can write this as AB plus BC equals 2AC. We're just one step away from getting the answer. Recall that A, B, C, all three were non-zero, so when you multiply them, again, A into B into C is a non-zero number. So when I divide both sides by A into B into C, that's a valid step. When I do that, what do I get? I get 1 by C plus 1 by A equals 2 by B. And what does this mean? This simply means that A, B and C are what? Or rather, I should say 1 by A, 1 by B and 1 by C are in arithmetic progression, and therefore A, B and C are in harmonic progression. So coming from sequence and series is the next question. It says 5 numbers are in AP, that is arithmetic progression, such that their sum is 25 and their product is 2520. If one of the numbers out of these 5 numbers is minus half, find out the greatest number out of these 5. So of course the question is asking us to decode the A and the D. Why? Because the moment I begin the question, I assume the 5 numbers which are in AP to be A minus 2D, A minus D, A plus D and A plus 2D. So the target is to compute A and D appropriately and then fetch what is the greatest number out of these 5. So if the sum of these 5 is 25, that means when you add all these, you get 25. When you do that, you simply get a 5A equals 25, which in the next step gives you A equals 5. So A is simply decoded. From the next given condition, which is the product of these 5 numbers is 2520, let's see if we can decode D appropriately. That's the common difference. So when I multiply all these 5, I'm getting 2520. Just plug A equals 5 that we just found, and the entire equation will be in terms of D, in fact, D square. So you will get 25 minus 4D square multiplied by 25 minus D square equals 504. When I take D square to be equal to T, just for convenience, and then solve and simplify further, what I get is 4T minus 121 into T minus 1 equals 0. Basically, you get a quadratic equation in terms of T, and when you factorize it, you get these two as the factors. Obviously, equating each one of them with 0 gives you T equals 121 by 4 and T equals 1. Now, T is nothing but D square. So in a way, I'm getting 4 values of D. Are you understanding? D can be plus 1 or minus 1 or plus 11 by 2, minus 11 by 2. Now, let's begin with plus minus 1. They are easier values to start with. When you have A as 5 and D as plus 1, try to find out all these 5 numbers. You will realize that all of them are coming as integers. You take A as 5 and D as minus 1, plug the values in all these 5 numbers, and the 5 numbers that you get as a result are again all integers. But read the question nicely. It says one of the numbers is not an integer, it is minus half. That means we can't take D to be plus 1 or minus 1. That means D square equals 1. This possibility is eradicated. So we have just 2 possibilities left. That is, D can be either plus 11 by 2 or a minus 11 by 2. Now, the good thing is that when you take A as 5 and D as 11 by 2, the 5 numbers that you get are exactly same that you get when you take A as 5 and D as minus 11 by 2. The only difference is that when you take D as plus 11 by 2, the greatest number out of these 5 is given by A plus 2D. So what is that? Let's find the value. Plug in A equals 5 and D as plus 11 by 2. You get what? 5 into twice of 11 by 2, which gives you 5 plus 11. That is 16. And when you take D as minus 11 by 2, in that case, the greatest number obviously is given by A minus 2D. So plug in A as 5, D as minus 11 by 2. What you get is, again, 5 plus 11, that is 16. So this was one observation. That's it. Otherwise, your answer, your final answer is 16. Okay, so this question says that alpha is a root of x square plus x plus 1 equals 0 quadratic equation. That obviously means the information here that is given to you indirectly is alpha square plus alpha plus 1 always whenever you see is going to be 0. Along with this, the question gives you the matrix A and asks you to find out what is going to be A to the power 31 matrix. Now, obviously in such questions, we try to form a pattern, right? So with A, we are first of all going to compute A square by simple matrix multiplication, the row column multiplication. It's very, very easy. Multiplying A with itself is going to give you A square. When you perform the multiplication, the answer that you get is 100, 001, 010. Row wise, I just read it, this to be A square. Now A square you have, right? Let's compute A square whole square. That's easier to form the pattern, isn't it? So A square whole square, that means A to the power 4, or rather I can say A square into A square. Again, multiplying A square with itself is going to give you the identity matrix. And that's where your solution almost comes to an end, because you realize that a to the power 4 is coming out to be identity. That means a raised to any power which is multiple of 4 is going to keep on coming out identity matrix. So if a to the power 4 is identity, a to the power 8 is identity, and so on. Last, I'm going to stop at a to the power 28 being identity. Because after that, I'm going to have a to the power 32 as identity, and I want a to the power 31's value, right? So let's not go beyond 31, it's of no use. So I'm going to express a to the power 31 with the help of a to the power 28, isn't it? That is what the drill is. So a to the power 31 means what? 28 plus 3 is 31. So a to the power 28 plus 3, that's what I can write it. Which makes it a to the power 28 into a to the power 3. That means I multiplied by a to the power 3, isn't it? Because a to the power 28 is identity matrix of order 3. Which leaves you with a cube to be the value of a to the power 31. And that's how, just by following the drill of forming a pattern, leaves you with the answer that a to the power 31 is equal to a cube within no time. Coming up next is this question, which gives you a relationship in between x and y, that x to the power k plus y to the power k is a to the power k, but k is some constant which is positive, and this a that you can see is also some constant which is positive. Also, you are given that dy by dx plus y by x whole to the power 1 by 3 is 0, this differential equation. Now in here, we have to find the value of k. So obviously this question is about implicit differentiation. We catch hold of this relation and actually differentiate both sides with respect to x and try to get dy by dx. What do we get? Let's just try to do this. Okay, so this is x to the power k plus y to the power k equals a to the power k. Let's differentiate both sides with respect to x. You get k x to the power k minus 1, right? And then you have plus k into y to the power k minus 1 dy by dx. Just applying the chain rule, equals a to the power k is a constant, so its differentiation is going to be 0. Okay, well, this is pretty simple now. You get k y to the power k minus 1 dy by dx equals minus of k x to the power k minus 1, right? So your k gets cancelled, it's positive, right? So your dy by dx comes out to be equal to x by y whole to the power k minus 1. But wait a second. The original differential equation is dy by dx plus y by x to the power 1 by 3. So if I write this as y by x, this is going to be y by x to the power minus of k minus 1, that is 1 minus k, isn't it? Now that I have this, both the differential equations are actually same. So let's compare them. One is dy by dx plus y by x to the power 1 by 3 equals 0, and so the other one is going to be dy by dx plus y by x to the power 1 minus k equals 0. So when you compare both these, what do you get? You get that 1 minus k will be exactly equal to 1 by 3. And when 1 minus k is equal to 1 by 3, you get 1 minus 1 by 3 as k. That means k is 2 by 3. So just by recalling the implicit differentiation concept, you get through with question, and the answer is k equals 2 by 3. Coming up next from the world of complex numbers, we have this question. It says that z is x plus iota y such that this z satisfies a condition that real part of z minus 1 upon 2z plus I is equal to 1. Then, following this condition, find out the locus of the complex number z. So of course the drill in such questions is pretty straightforward. We try to actually compute z minus 1 upon 2z plus I in terms of x and y. Right? Because that is going to take us towards the very locus of z. So without any further ado, let's just do this. We have z minus 1 upon 2z plus I. In place of z, you plug in x plus iota y. What do you get in the numerator? I'll just write the real parts together and the imaginary together. I have x minus 1 plus iota y. Denominator becomes what? Twice of x plus iota y plus iota. So again, club all the real and the imaginary parts together. So you get 2x plus iota times 2y plus 1. Isn't it? You have 2x, yes, you have 2 iota y, yes, and you have iota. Okay. Now, in order to simplify this, the very basic thing is to rationalize, isn't it? Or rationalize means I'm going to multiply and divide by the denominator's conjugate complex number. So that is going to be pretty straightforward. I'll multiply by 2x minus iota times 2y plus 1 and divide by the same thing, 2x minus iota times 2y plus 1. Now, when you actually solve this is just going to be your analytic calculations. So using the properties of iota, when you solve this, what you get is a complex number with this as the real part, okay, and something as the imaginary part. I'm not interested in that. Okay, so this is how the complex number looks, which comes out when you solve this big large expression. Why I'm not concerned with the imaginary part is because the question said real part of this expression is 1. And from our calculation, this is what is the real part coming out to be. Right? So that's why I'm not interested with the imaginary part of this complex number. So if real part of this is 1, that means this expression is what is 1. And you can see this equation has given you a relation in terms of x and y. We just have to solve this to the maximum possible limit and from there extract out the very, curve of which it's the equation. So when you solve this, what you get is 2x square plus 2y square plus 2x plus 3y plus 1 equals 0. At this point of time only, you can say that yes, it's a circles equation, but let's simplify that even further. Let's make the coefficients of x square and y square as 1, dividing throughout by 2. What do I get? X square plus y square plus x plus 3 by 2y plus 1 by 2 equals 0. This is the equation of the circle and therefore the answer is that the locus of z is a circle. But then when you look at the options related to the circle, the option talks something about the diameter of the circle. So let's extract out the radius and hence the diameter of the circle. For that, realize that this equation is of the form x square plus y square plus 2gx plus 2fy plus c equals 0, the standard general form of the equation of a circle. So let me write this as that only. X square plus y square plus 2 into g into x. I can write it like this, where this is my g, plus 2fy, so 2 into 3 by 4 into y, this is my f, plus c, that is 1 by 2 equals 0. Obviously, minus g comma minus f is going to be the center of the circle, that is minus 1 by 2 comma minus 3 by 4. I'm not so much interested in the center, I'm interested in the diameter. For that, I need the radius. Radius is nothing but under root of g square plus f square minus c. That means under root of 1 by 4 plus 9 by 16 minus 1 by 2. When you solve this, what you get is nothing but a root 5 by 4, and that is my radius, and therefore the diameter is going to be twice of root 5 by 4, that's root 5 by 2. Got it? And that's how you tackle this question. The answer is that it's a circle with the diameter root 5 by 2. Coming before you is this question again from differential equations. It gives you y as a function of alpha, as you can see, involving the trigonometric functions, such that this alpha is belonging in the open interval 3 pi by 4 to pi. The question is asking you to find dy by d alpha at alpha equals 5 pi by 6. So it's a pretty straightforward question. We have y with us if to compute dy by d alpha. Obviously, the strategy is to simplify y as much as we can so that when we proceed to differentiate it with respect to alpha, it should not take much time. So let's work upon y and simplify it as much as we can. You can see in y, there is tan involved, cot involved, and there is a sine square alpha involved. So that is enough to give you a hint to convert tan and cot in terms of sine and cos. When you do that, when you write tan as sine upon cos and cot as cos upon sine, take out the LCM and get a simplified version of this expression, you are going to get y to be equal to positive square root of 2 cos square alpha upon sin alpha into cos alpha plus that 1 by sin square alpha as it is. So in here you can see this cos alpha cancels out. You're left with 2 into cos alpha upon sin alpha, that is 2 cot alpha, plus 1 upon sin square is nothing but cosec square alpha. Now if I write cosec square as 1 plus cot square, you can see what I have inside the square root. I have cot square alpha plus 2 cot alpha plus 1, which is a perfect square, and I can write that as 1 plus cot alpha whole square. So this is what my y is now. And of course, what I write in the next step is going to be mod of 1 plus cot alpha. Now recall the condition over alpha. Alpha was belonging in the interval 3 pi by 4 comma pi. If alpha is in this interval, recall that for these values of alpha, cot alpha is always strictly less than minus 1. Right? You can recall that from the graph if you're aware about it. And this in the next step I can write it as cot alpha plus 1 is definitely going to be less than 0 for alpha coming from here. If 1 plus cot alpha is less than 0 for these values of alpha, that means mod of it is going to be minus of 1 plus cot alpha by the definition of the mod function. So this is simply going to be minus of 1 plus cot alpha. That means minus 1 minus cot alpha. So you see from where we have just dissolved our y function, which was in terms of alpha, to a simple expression that is minus 1 minus cot alpha. Let's now just jump to differentiate this with respect to alpha. Well, when you do that, when you find out dy by d alpha of minus 1 is 0. You get minus of d by d alpha of cot alpha. That means minus of minus cosec square alpha, which is nothing but a plus cosec square alpha. Now that you have your dy by d alpha as cosec square alpha, let's just quickly find out its value at alpha equals 5 pi by 6. So we have to find out cosec square of 5 pi by 6, that means cosec of 5 pi by 6 whole square. Cosec of 5 pi by 6, you know, come on, all these trigonometric rules and the very identities that you've learned, that cosec of 5 pi by 6 is equal to 2, and therefore its square is going to be a simple 4, and that is how you get the answer of this particular question, that is dy by dx at alpha equals 5 pi by 6 to be equal to 4. That's your answer. Take a look at this question now. It says that what is the largest value of k for which 49 to the power k plus 1 is a factor of this given expression. So of course these are some famous variety of questions, isn't it? You know what to do in here. We try to express this expression in terms of 49 to the power k plus 1 for some k. And that is what leads us to the answer eventually. So if you look at this expression, this is 1 plus 49 square plus 49 cube and so on till 49 to the power 125. Well, it's pretty evident it is nothing but a GP. And if I just share with you the concept, make you recall the concept, okay? What is that? Well, if you have 1 plus x squared and so on till x to the power 125, where say your x is greater than 1, what is this sum equal to? This is sum of a finite GP, isn't it? So in here, if this is your GP, your first term is 1 and your common ratio is x, which is greater than 1, right? So this sum is given by what? A, r to the power n minus 1 upon r minus 1, where n is the number of terms in this sum. You can see there are 126 terms in this sum, so this n in here will simply be replaced by 126. Okay, so this is nothing but your a is 1, so you get x to the power 126 minus 1 upon x minus 1. Exact same thing I will be writing for x equals 49, isn't it? Because that is what the expression in here is. So this entire sum is going to be nothing but what? 49 to the power 126 minus 1 upon 49 minus 1, that's 48. Of course, I have to write it in terms of 49 to the power k plus 1. I don't have something like that in here. But I do realize that if I treat 1 as 1 square and 49 to the power 126, just try to factorize 126, you'll be able to realize this is 2 into 6, 12, and 2 into 3 is 6. That means you can write 126 as 63 into 2, which makes you write this in the next step 49 to the power 63 whole square minus 1 whole square upon 48. Now this is of the form a square minus b square, which is a plus b into a minus b. That means 49 to the power 63 plus 1 into 49 to the power 63 minus 1 upon 48. And bingo, you have been able to write this expression in terms of 49 to the power something plus 1. And that something in here is 63. So when I divide this expression by 49 to the power 63 plus 1, of course, from the numerator and denominator they get cancelled, but what you're left with after that is 49 to the power 63 minus 1 by 48, and this better give you an integer as the answer, because then only you can say yes, 63 is going to be our final answer. So let's see whether 48 is able to divide the numerator in here or not. If it has clicked within you, well and good. Otherwise, let me help you with the answer of this question. I can write 49 in terms of 48 as 1 plus 48, and therefore I get on the right hand side 1 plus 48 to the power 63 minus 1 whole upon 48. Obviously in here I'm going to use my binomial theorem, and that is going to give us what? 1 plus 48n plus nc2 48 square plus nc3 48 cube, and so on till 48 to the power n. N in here obviously I'm substituting in place of 63, and this minus 1 comes in here as it is. Okay. So plus 1 minus 1 cancels out what you see in the numerator. Each and every term is a multiple of 48, so I can extract out the 48 common. I will be left with n plus nc2 into 48 plus and so on 48 to the power n minus 1 whole upon 48. And that is enough to convince you that yes, 48 cancels out. What you're left with is this term, which is completely an integer. So now we are completely convinced that yes, 63 is the largest value of k, for which 49 to the power 63 plus 1 divides this entire expression completely, right? So in this question, we have been given that there is a triangle ABC, and the coordinates of the vertices of this triangle are given to us. So we have the coordinates of A known, B known, and C known. The question is talking about a point P, because of which there are three triangles being created. One is triangle APB, other is BPC, and other is APC, such that these three triangles have equal area. Okay, read the question very carefully. Then the question gives you another point Q along with its coordinates and asks you to find the distance between P and Q. So of course Q is known to us. Just if I have the coordinates of P with me, by using distance formula, within no time we can calculate the distance between P and Q. So how in the world am I going to get the coordinates of the point P? Examine the feature, the characteristic of point P. Point P is creating the three triangles in picture, right? Triangle APB, BPC and APC. Of course, P is lying somewhere in the interior of this triangle, for sure, such that the three triangles have equal area. Now, any triangle you take a point in the interior of it. Of course, you get three triangles within that big triangle always. But an interior point which is creating those three triangles such that they are equal in area is just one point, that is the centroid of this triangle, right? So if because of this P, these three triangles are having equal areas, this point P better be the centroid of this triangle. This is the only catch in here. After that, this is enough for him to get the coordinates of point P, isn't it? The moment we have found out that P is going to be the centroid of this triangle, what is going to be the x-coordinate of point P? It's going to be nothing but the arithmetic mean of the x-coordinates of the points A, B and C. That means 1 plus 6 plus 3 by 2 whole upon 2, right? So 1 plus 6 plus 3 by 2 whole upon, this is the x-coordinate of point P, and y-coordinate is going to be the arithmetic mean of the y-coordinates of the points A, B and C. That means 1 plus 5 plus 2 whole upon 2. And here it is going to be 1 plus 5 plus 2. Yeah, 1 plus 5 plus 2 whole upon 3. Right. When you solve this, it's just pretty calculation. You're going to get 17 by 6 as the x-coordinate and 8 by 3 as the y-coordinate. right? So your P point is this. And now the question is almost over. You have your P with you, you have your Q with you. Apply the distance formula. Well, if I take this as x1, this is y1, this is x2, this is y2, then your distance formula is under root of x2 minus x1 whole square plus y2 minus y1 whole square. This is going to give you what? This is going to give you 17 by 6 plus 7 by 6, that is 24 by 6 whole square, plus 8 by 3 minus of minus 1 by 3, that means your 9 by 3 whole square, which is nothing but under root of 25, which is a 5. Pretty question. The only thing to be decoded here was that P is the centroid of triangle ABC, and after that, the question was a child's play. The answer to this question is 5. Okay, so this is the next question. It says, f is a function which is continuous and differentiable in this closed interval, minus 7 to 0. F dash x is less than or equal to 2 for every x in this interval. Also, f of minus 7 is given as minus 3. Then we have to find out the range of f of minus 1 plus f of 0. Right, that means what is the very range of this particular expression, f of minus 1 plus f of 0. Okay, so how do we proceed? Of course, the function is continuous and differentiable in a certain closed interval. Reminds you of the mean value theorems, isn't it? So if I move towards the LMVT, the Lagrange mean value theorem, what pops up? F is a continuous function in minus 7 to 0 closed interval. Yes. F is a differentiable function in minus 7 to 0 closed interval. Yes. So there will exist a C in open interval minus 7 to 0 such that f dash C is f of b minus f of a upon b minus a. So this is my a, this is my b. So when I substitute, what do I get? F of 0 minus f of minus 7 upon 0 minus minus 7, that is 7. Right. Now the condition was that f dash x is less than or equal to 2 for every x in this interval. In fact, minus 7 to 0 closed interval. Now the c is also belonging in here. So f dash c is also less than or equal to 2. Right? So from here, what do you get? F of 0 minus f of minus 7 is less than or equal to 14. Now f of minus 7, the question says is equal to minus 3. So in place of this, when I write minus 3, what is the next thing that I get? I get f of 0 is less than or equal to 14 minus 3, that's 11. So from here, I'm getting an approximate range of f of 0. That means f of 0 is at most 11. It is less than or equal to 11. Right, so f of 0 is belonging in which interval? Minus infinity to 11 closed. I want the range of f of 0 plus f of minus 1. So one thing to observe in here is when the upper limit in here was 0. Basically, the interval was minus 7 to 0 closed, right? So that upper limit 0 gave me the value of f of 0. If the upper limit is kept as minus 1, somehow I'm going to get the maximum value or the range of f of minus 1, and that's what I want, right? So if a function is continuous and differentiable in minus 7 to 0 closed interval, it obviously is continuous and differentiable in any subset of it, that is minus 7 to minus 1 closed interval as well. So the exact same thing I'm going to replicate in that interval, which is minus 7 to minus 1 closed interval. So in here, when I apply my LMVT, again, there will exist some c dash in this interval such that your f dash of c dash is equals to f of minus 1 minus f of minus 7 upon minus 1 minus minus 7. That means 7 minus 1, that means 6. Again, the same thing, f dash of c dash will be less than or equal to 2, isn't it, according to what is given in the question? And then in the next step, you get f of minus 1 minus f of minus 7 is less than or equal to 12. Again, the exact same thing, f of minus 7 is given as minus 3. So you get the upper limit of f of minus 1 as well. You get f of minus 1 is less than or equal to 9. Right. So now by using 2 times LMVT, okay, smartly, I get f of 0 is less than or equal to 11 and f of minus 1 is less than or equal to 9. So f of 0 plus f of minus 1 will be less than or equal to 11 plus 9, that's 20. So what do I get? I get f of 0 plus f of minus 1 is less than or equal to 20, or the range of this expression f of 0 plus f of minus 1 is what? Minus infinity to 20 closed here, right? And that is what is your answer for this question. so 3D geometry comes up next. The question says that there is a plane consisting of these 3 points. So there are these 3 points sitting on this plane. The points are 2, 1, 0, 6, 3, 3, and 5, 2, 2. We have to find out the image of the point 2, 1, 6 on this plane. So first of all, in order to find the image of a point with respect to a plane, what do we need? What do we need is the equation of the plane, right? And how do we get the equation of the plane when we have the information of 3 points sitting on it? It's pretty simple. The very first task is to find the normal vector of this plane. So how do you do that? We have 3 points. 3 points can contribute to give us 2 vectors. One is going to be the AB vector, other is going to be the AC vector. When you find out the AB and the AC vector, which is very, very simple, you can compute this within no time. You take their cross product, right? Cross product of AB vector and AC vector gives you a vector which is normal to this plane, which is the normal vector of this plane, n vector, right? So let's take the cross product of AB vector and AC vector. That is going to give you I cap plus j cap minus 2k cap. This is your, I can say, AI cap plus BJ cap plus CK cap, right? Where your A is 1, B is 1, and C is minus 2. A, B, C are the direction ratios of this plane. Now this plane, normal vector is known to us. Catch hold of any one point sitting in this plane. Let me catch hold of point A, that is 2, 1, 0. I'm going to treat it as x1, y1, z1. So now I have n vector with me. I have the coordinates of one point sitting on the plane with me. So I can get the equation of the plane now by using the very formula. That equation of this plane is given by A times x minus x1 plus B times y minus y1 plus C times z minus z1 equals 0. A, B, C are nothing but 1, 1 and minus 2. x1, y1, z1 is nothing but 2, 1 and 0. Just plug all these things here and solve. What you get is x plus y minus 2z equals 3 to be the respective equation of this plane. Now that I have the plane's equation with me, I just need the image of point P with respect to this plane, right? Everything is known to us now, a direct concept, and we have the answer, right? So now I have the point as 2, 1, 6. The plane's equation is known to me as x plus y minus 2z equals 3, which deliberately I'm going to write it as x plus y minus 2z minus 3 equals 0. And now, as I said, direct concept is going to give you the coordinates of point Q, which is actually representing the image of point P, which is 2, 1, 6 with respect to this plane. Got it? Fine. So what do we do? How do we get the coordinates of point Q? Well, I'm sure you would be knowing that. Let me just help you recall it. So this is given by x minus 2 upon this 1 equals y minus 1 upon this 1, okay, equals z minus 6 upon this minus 2, that is coefficient of z, equals to minus 2 times, that is what you should remember when it comes to the image, minus 2 times what? Well, in this entire left hand side, wherever there is x, y and z, you plug in the x, y and z coordinates of point P. So you are going to get what? 2 plus 1 minus 2 into 6 minus 3, right? All of this upon a square plus b square plus c square. That means 1 square plus minus 2 whole square. That means 1 plus 1 plus 4. That is a 6, right? So let's just resolve this a bit. Okay, so we have 2 plus 1 is 3. 3 minus 3 gives you 0. You're left with minus 12 into minus 2, that is 24. 24 by 6 just gives you a 4. So this entire right hand side comes out to be 4. Now, one step away we are from the coordinates of point Q. When you equate x minus 2 by 1 with 4, you get x equals 6. When you equate y minus 1 by 1 with 4, you get y equals 4 plus 1, that's 5. And when you equate z minus 6 by minus 2 with 4, what you get is z minus 6 equals minus 8. So you get z equals minus 8 plus 6, that's minus 2. And that bingo gives you the coordinates of point Q as 6, 5, minus 2, which is actually representing the image of point P with respect to this plane. Okay, then coming from binomial theorem is this question which says sum of all coefficients of even powers in this particular expression is 61. Now, of course, you don't sit to multiply all the terms and actually find out what it comes out to be, but tackle with it a bit smartly. We have to find the value of n eventually. So, of course, when you multiply both these bracketed terms, you get a polynomial expression, isn't it? How difficult is that to guess? So the polynomial expression is going to look something like a0 plus a1x plus a2x squared plus a3x cubed and so on. Now this is true for every x real, isn't it? For every x real this is true. So let's start plugging in randomly by hit and trial some nice good looking easy real numbers and see what all are we getting. So beginning with x equals 1. When I plug in x equals 1, what do I get in here? This bracket consists of 2n plus 1 terms, right? Start plugging in x equals 1, you get 1 minus 1 plus 1 minus 1 plus 1 minus 1 and so on. Don't forget there are 2n plus 1 terms. So 2n terms will be cancelled out, but that one single 1 is going to still remain. So when you plug in x equals 1, this first bracket gives you 1. And on the right hand side bracket, when you plug in x equals 1, you get 1 plus 1 plus 1 plus 1 and so on 2n plus 1 times. So 2n plus 1 is the answer. So entire left hand side comes out to be 1 into 2n plus 1, that's 2n plus 1. Now, actually in that polynomial expression a0 plus a1x and so on, when you plug in x equals 1, what do you get? a0 plus a1 plus a2 and so on. Okay, this is, let me say, equation 1. Now let's plug in another value, real value in place of x. So when you plug in x equals minus 1, what do we get? Okay, in that case, this bracket gives you what? It gives you 1 minus 1 plus 1 minus 1 plus 1 minus 1 and so on. Again, realize there are 2n plus 1 terms. So 2n terms will be cancelled, but yet you will be left with a single 1, isn't it? You can see the power x to the power 2n, it's even power. So you'll be left with 1. So right hand side bracket gives you 1 when you plug in x equals minus 1. And left hand side bracket gives you what? 1 plus 1 plus 1 plus 1 plus 1 and so on 2n plus 1 times, so it is 2n plus 1. Okay, so entire left hand side comes out to be 2n plus 1 into 1, that's 2n plus 1, and right hand side comes out to be what? In that polynomial expression a0 plus a1x and so on, when you plug in x equals minus 1, you get a0 minus a1x plus a2x squared minus a3x cubed and so on. So you have two equations with you, right? Of course you can see that a1 and minus a1 can get cancelled, plus a3 and minus a3 can get cancelled. So why not we add both these equations to get a simplified version? Okay, a simplified relation which involves n and somehow is capable of giving me the value of n. So when I add both these equations, I get twice of 2n plus 1 on the left hand side. And of course this a1 and minus a1, a3 and minus a3, all of that gets cancelled. You are just left with even coefficients. Or I should say coefficients of even powers in this polynomial expression a0 plus a2 plus a4 plus a6 and so on. So your expression becomes what? Twice of 2n plus 1 is equal to a0 plus a0 plus a2 plus a2 plus a4 plus a4 plus a6 plus a6. Isn't it? That means twice of a0 plus a2 plus a4 plus a6 and so on. Okay, so this 2 gets cancelled. This is still 2n plus 1, and the right hand side you try to word it up. This is the sum of coefficients of even powers of x in this expression only, because this is what was equal to this, right? And the question said that is given to us as 61. So what I'm going to do is, in place of this, I'll just plug in 61, and that is the drill in here. You're one step away to get your n. Your 2n is 61 minus 1, that's 60. So your n is nothing but 30. And bingo, you've got the answer. The very value of n in here is 30. So in here we have the question from probability. What does it say? It says that a coin, an unbiased coin, is tossed 5 times, and what is happening is that head is occurring simultaneously, or I should say head is occurring consecutively. How many times is what is the concern of the question. If heads is occurring consecutively 3 times, 4 times or 5 times, then capital X is given to be equal to K, where K is representing the number of times your heads is occurring consecutively. So capital X is 3, when k is 3, capital X is 4 when k is 4, and capital X is 5 when k is 5. Understood? We have to find out the expectation. So when capital X is equal to k for k equals 3, 4 and 5, what is the respective probability? Let's find out. So probability of k equals 3 is going to be probability that heads is occurring consecutively 3 times. Right? That can happen in what all situations? You can very easily decode this. Head can occur consecutively 3 times either in this particular outcome, or when the outcome is this, or this, or this, or this. Now when you are tossing a coin 5 times, the total number of outcomes is 2 to the power 5, that's 32. And out of those outcomes, 5 outcomes are there in which head is occurring consecutively 3 times. So 5 by 32 is the probability of k equals 3. Similarly, what is the probability of k equals 4? That means heads is occurring 4 times consecutively. That can only happen in 2 situations, when this is the outcome or this is the outcome. So 2 by 32 is the probability. And heads is occurring consecutively all 5 times. That means in all 5 throws I have heads. That can happen only in one outcome, when the outcome is H, 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 H. Right? So the probability is 1 by 32. Okay. What is the probability of the event when I am not getting heads occurring consecutively 3 times or 4 times or 5 times? So when head is occurring consecutively 3 times, I'll just name this event as 3. Heads occurring consecutively 4 times, let me name this event for convenience as 4. And similarly, when head occurs consecutively 5 times, that event is 5. So when heads is not occurring consecutively 3 times or 4 times or 5 times, what is the probability of that event? Which is probability of neither 3 nor 4 nor 5. That is going to be what? 1 minus probability of event 3 union event 4 union event 5. Isn't it? What is that? Well, each of these is mutually exclusive. So probability of neither 3 nor 4 nor 5 is going to be 1 minus probability of 3 plus probability of 4 plus probability of 5. All these we have already calculated. So when you perform the calculation, you get 24 by 32. Okay. So now I have probabilities of all the possible events. When heads is occurring consecutively 3 times, 4 times, 5 times, and when this is not happening. Right. So now I want the expectations. That is going to be what? Well, expectation I want. So as the question said, that capital X is equal to 3, 4, 5 when k is 3, 4, 5. So corresponding to those terms, I'm going to have 3 into p of 3 plus 4 into p of 4 plus 5 into probability of 5 plus the rest. Right? The question says X is minus 1 in the rest of the cases. So you get minus 1 times probability of 3, 4, 5 not happening. That means minus 1 times probability of 3 bar intersection 4 bar intersection 5 bar. And that is what we just calculated to be 24 by 32. So you plug all the values in here and you perform the calculation. It's very, very simple. It just comes out to be 4 by 32. Okay, or you can write this as 1 by 8. Right? And that is your final answer for the expectation. Got it? Coming from the house of definite integration, we have this question, which gives you that f is a function such that f of a plus b plus 1 minus x is equal to f of x for every x real. Based upon this information, we have to find out the value of this integral, right? So we're going to take this integral as capital I. Let's just try to compute capital I. Now, the very one property which is utterly important in definite integration is what is going to be directly used in here, because that's the first thing that pops up when a question based upon definite integration comes up, isn't it? That's one property which we always try to apply, and we really hope that it takes us somewhere. So let's do that. That property is nothing but integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. So that's what I'm going to do in here as well. If my capital I is this integral, capital I is going to be this integral when I replace x by a plus b minus x. So when I do that, what happens? This is replaced by a plus b minus x. This is replaced by a plus b minus x. And this is replaced by a plus b minus x. Right? So I get that capital I is equal to 1 by a plus b as it is, integral from a to b. a plus b minus x multiplied by f of a plus b minus x plus f of a plus b plus 1 minus x the whole dx. Now this is something that the question said is equal to f of x. So what I'm going to do is, in place of this expression completely, I will just write f of x. What about this expression? This is not a plus b minus x plus 1. Just a plus 1 is missing, right? So that's, I think, pretty much a hint to get its value from here only. So if I talk about f of x plus 1, if f of x is this, f of x plus 1 will be what? F of a plus b plus 1 minus of x plus 1. I just replaced x by x plus 1. So this becomes f of a plus b plus 1 minus x minus 1. This gets cancelled out and you are left with f of a plus b minus x. That was the bingo step in here. If f of x is given to you like this, f of x plus 1, you can really find out that is equal to f of a plus b minus x. So here f of a plus b minus x can be replaced by f of x plus 1. Got it? Yeah? Okay. So now I have two i's with me, right? I'm going to express this as 1 by a plus b integral from a to b x f of x plus x f of x plus 1 dx. Just opening it up. Okay, this is 1. Similarly, let's open this up, 1 by a plus b as it is, integral from a to b. And then you have a plus b times f of x plus 1. I'm deliberately clubbing a plus b together because in the denominator I have a plus b, right? Perspective. So I write this as a plus b times f of x plus 1 minus x times f of x plus 1. Similarly, plus a plus b times f of x minus x times f of x, the whole dx. This is my second expression for I itself. What do you do next? You add the two, you get 2i on the left hand side, and on the right hand side, what do you get? You get x fx plus x times f of x plus 1 plus a plus b times f of x plus 1 minus x times f of x plus 1 plus a plus b times f of x minus x times f of x inside the integral with 1 by a plus b sitting outside. Right, so this is what you get, isn't it? 2i on the left hand side. And of course, there are clear-cut cancellations happening in here. This is your plus x f of x. This is minus x f of x. This is your minus x f of x plus 1. This is plus x f of x plus 1. You can see this a plus b is common. It will be extracted out of the integral sign. This gets cancelled and you're left with integral from a to b, f of x plus 1 plus f of x dx. So now, if I write this as integral a to b f of x plus 1 dx, plus integral a to b f of x dx. Well, realize the property that integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. If I use again in here, in this integral, I replace this x by a plus b minus x. The integral is not going to change, right? So in place of x plus 1, I can write a plus b minus x and plus 1. Isn't it? But wait a second, what did I just create? F of a plus b minus x plus 1, the question said, is equal to f of x. So this gets converted to f of x. Right? Now you can see what this expression has been converted into. This is twice of integral a to b f of x dx. So you get 2i is equal to twice of this integral. That clearly means your I is nothing but this integral, which is integral a to b f of x dx, and that is enough to give you the very value of I, that is equal to nothing but integral a to b f of x dx. So in here we just got I equals integral a to b f of x dx, but you carefully observe the options. None of the options consist of this as the expression written. That means what actually should we do? So look at the options. The limits are a minus 1, b minus 1, right? So there is enough a hint to do some substitution in here, because we've arrived at the solution, but the look of the solution is somehow not matching with the options. So we just need to work on the look, right? And that is nothing but substitution technique. So if I take x as t plus 1, okay, Obviously, dx remains as dt, but the limits change. If x is a, this implies your t is going to be a minus 1, right? So lower limit gets converted to a minus 1. And if your x is b, that is the upper limit, then corresponding upper limit will be b minus 1. So the exact same integral gets converted to what? A minus 1 to b minus 1 f of t plus 1 dt, right? Somehow this is matching with the fourth option, just if I replace t with x. Can I do that? Of course, x and t are dummy variables. What are you waiting for? You can write this as a minus 1 to b minus 1 f of x plus 1 dx, and that is sitting as option number 4, the fourth option, the last option, and that completes this question. Well, next question coming from the chapter Permutations and Combinations. Let's see what it says. So the question is giving you 5 digits, 1, 3, 5, 7 and 9. And the question is, how many 6-digit numbers can you form by using these 5 digits and also by exhausting all these 5 digits? Okay, so you get the question. I'm only allowed to use these 5 digits firstly. Secondly, I have to exhaust all these 5 digits in each of the 6-digit number that I form. So now we're going to deal with this question in parts. First of all, in a 6-digit number, there are 6 places, right? First 5 places, or 5 places basically, will be filled by all these 5 digits, isn't it? So there is only one way to fill up 5 places out of the 6 places in a 6-digit number. Why one way? Because 5c5 gives you 1. So selecting all 5 digits has only one way, that is 5c5, so that's 1, right? Okay, 1, that means 5c5. Now in a 6-digit number, I have kept or basically filled the 5 places. 1 place is still left. And that 1 place which is left has to be filled up by a digit out of these 5 only, right? We got the language of the question very clear. So 1 place to be filled out of these 5 digits, that can happen in 5c1 ways, right? 5c1 is what? Just a 5. So, okay, now that I have all the 6 digits ready with me, you realize I have to permute them in all possible fashions to get all the available 6-digit numbers, right? Now, what are the digits I have to permute? The digits that I have to permute are 6 digits in which 2 are identical. Realize that? These 5, 1, 3, 5, 7, 9 are filling up 5 places, and the 6th place is filled up by 1 digit out of these 5 only. So there are 6 digits out of which 2 are identical and I have to permute them. So how many ways are there to do that? Well, 6 factorial, because in total there are 6 digits, but then 2 are identical, so I divide by 2 factorial. Isn't it? So you get 1 into 5, that was nothing but 5c5 into 5c1 into 6 factorial by 2 factorial as the total number of 6-digit numbers which are formed by using these 5 digits and under the condition that I exhaust all these 5 digits. This, when you solve very simply, comes out to be 1800, and therefore 1800 is your final answer. Okay, so the question from limits is here. We have to find the limit of this expression as x approaches to 2. Now, the very first thing, when you plug in x equals 2 in the numerator and the denominator, you see both of them turn out to be 0. And therefore, this expression is a 0 by 0 form. What do we do in here? The very first step is to simplify it as much as we can. Okay, you can see in the numerator there is a 3 to the power x minus 1 sitting. In the denominator you have 3 to the power 1 minus x sitting. So let's just get rid of all these expressions and make this as much simplified as possible. So the numerator, I'm going to transform it as 3 to the power x as it is. Next will be 3 to the power x upon 3 and minus 12 as it is. The denominator, I can write it as 1 upon 3 to the power x by 2 and then minus 3 upon 3 to the power x, right? Now you can see both these I can club and find out the LCM. I am going to have 3 to the power x plus 1 plus 3 to the power x whole upon 3 minus 12 and the denominator as it is. Now from here and here you can take out 3 to the power x common. You will be left with a 3 plus 1, that's 4 inside the bracket, and rest of the terms I'm not disturbing. Okay, now that I have this as pretty much a simplified version of my original expression, what I can infer from here is that the expression involving x is either of the form 3 to the power x or there is a 3 to the power x by 2. These are the only two ways in which this term, this x, is involved in this expression. And don't forget the limit is over x itself. So what do we do in here? Either we have a 3 to the power x by 2 or we have a 3 to the power x. So of course, the direct thing which strikes is that why not consider 3 to the power x by 2 to be equal to some easier variable, say t. If I take 3 to the power x by 2 equals t, my expression is going to be further simplified. Moreover, if this is t, what is 3 to the power x going to be equal to? I can write this as x by 2 into 2, right? That means 3 to the power x by 2 square, that means t square. So wherever there is 3 to the power x by 2 written, I will be replacing it by t. Wherever there is 3 to the power x written, we'll replace it by t square. And what about the limit? If I'm changing the variable from x to t, the limit is also now going to run over t. So if x is approaching to 2, x by 2 is going to approach to 2 by 2, that's 1. So 3 to the power x by 2 will approach to 3 to the power 1, that's 3. So when x approaches to 2, t approaches to 3. Got it? So this expression is now converted completely in terms of t. It is going to be what? Limit as t approaches 3 of what? 4t square by 3 minus 12 upon 1 by t minus 3 by t square. Got it? And now the question is a cakewalk, trust me. So this is going to be limit t tends to 3. This is 4t square minus 36 whole upon 3 multiplied by t minus 3 by t square. Okay. So in the next step, I write this as limit t tends to 3. This is 4 common t square minus 9. And upon I have, so t square, I'm going to bring it above from the denominator. Denominator, I have 3 into t minus 3. Now it's pretty evident t square minus 9 can be written as t minus 3 into t plus 3. So let's write it like that and perform the necessary cancellation. Okay, so this gets cancelled. And now what am I left with? You can see only the numerator now involves the expression of t. It is 4t square into t plus 3 and the denominator is a constant, that's 3. So what is this? You're left with nothing. The numerator is what is the deciding factor in here, which is nothing but a polynomial function in t. So you're just going to plug in t equals 3 in this expression and get the very answer. Your answer is going to be 4 into 3 square times 3 plus 3 whole upon 3, which when you solve comes out to be a 72. Cool? That's how you solve this question and the answer in here is 72. Well, this question is from statistics, from the topic variance specifically. It says that if the variance of first capital N natural numbers is 10 and the variance of first capital M even natural numbers is 16, what is the value of M plus N? Now, if you can recall this concept straight away, that the variance of first n natural numbers is given by n square minus 1 by 12, you are going to actually land to the very first equation that 10 is equal to n square minus 1 by 12. But if you're not that much convinced, let me just explain to you how you get this. So let me just start with taking first small n number of natural numbers. The claim is that the variance of these first n natural numbers is equal to n square minus 1 by 12. How do you get this? Well, this is the explanation. Sigma square, that is your variance for the first n natural numbers. Of course, you know the formula. It's given by what? Mean of the squares minus square of the mean. That's how you remember it, isn't it? So what is summation of xi square? That means 1 square plus 2 square plus 3 square and so on till n square. It is nothing but what? Sum of squares of first n natural numbers, which is nn plus 1 to n plus 1 by 6. Similarly, what is summation xi, where I is running from 1 to n, that means 1 plus 2 plus 3, so on till plus n, that means the sum of first n natural numbers. It is nn plus 1 by 2. When you plug in both these things in equation 1 and you solve it, what you get is sigma square equals n square minus 1 by 12, thereby convincing you that yes, the variance of first n natural numbers is n square minus 1 by 12. Got it? Now I don't think you are ever going to forget this. So we have our very first equation that the variance of first capital N number of natural numbers is equal to n square minus 1 by 12. So that is equal to 10 according to what is given to us. So when you resolve this, you simply get n square minus 1 equals 120 or n square equals 121 or your capital N, which is a natural number so it can't be negative, is equal to 11. We've just decoded the value of capital N. Let's now move ahead to decode the value of capital M, which is corresponding to the statement that the variance of first capital M even natural numbers is 16. That means 16 is given to be equal to variance of 2, 4, 6, 8 and so on till 2m. So 2m is the mth even natural number, right? What can you see? What can you see in these values? Can you see that 2 is nothing but 2 into 1, 4 is nothing but 2 into 2, 6 is nothing but 2 into 3 and so on. And this immediately makes me recall this very important property about variance, that variance of ax plus b is a square times variance of x. Here the role of a is being played by 2, right? So using this property I can write that this will be equal to variance of, or rather a square times, that is 2 square times variance of what? 1, 2, 3 and so on till m. Isn't it? This is the only catch in here. And then this is going to be your 4. And what is variance of 1, 2, 3 up till m? Well, I just shared with you this entire concept that the variance of first n natural numbers is n square minus 1 by 12. So variance of first capital M natural numbers 1, 2, 3, 4 up till m is going to be m square minus 1 by 12. So your right hand side just comes out to be equal to 4 times m square minus 1 by 12. That is equal to 16. So can you see you have this equation again, that 16 is equals to 4 times m square minus 1 by 12, that is nothing but m square minus 1 by 3. You can solve this straight away. This is going to give you m square minus 1 equals 48 or m square is 49. That means m is 7. You have m as 7, you have n as 11. That means m plus n that we had to find is going to be 11 plus 7, that is 18, and 18 is your very answer. Coming up next before you is this question, which is giving you a function f of x in terms of mod. It says it is equal to mod of 2 minus mod of x minus 3, and S is a set consisting of all those values of x for which this function f of x is non-differentiable. Once we've decoded what set S is, or what all elements S consists of, we have to find out the summation of f of x for every x sitting in the set S. That means the very first target is to compute the elements sitting inside set S. In other words, we have to compute all those inputs at which this function f is non-differentiable. Now, the moment you look at the definition of this function, one very easy way to tackle this question is to perform this particular question graphically. By just using the concept of transformation of graphs, within no time you will be able to actually look and visualize the function f, and then we're just going to detect the sharp-edged points, and that is going to give us the points of non-differentiability. So let's start. First of all, mod x function you plot. You all know the very graph of mod x, right? This is how it looks like. Now, if I want mod of x minus 3, I'll just shift this graph to the right by 3 units. So you see that at 0 now it is giving the value 3. This is the graph of mod of x minus 3. Now when I invert this with respect to x-axis, I get minus of mod of x minus 3. I add 2 to each of these values. The entire graph shifts 2 units upward. What I get is the graph of 2 minus mod of x minus 3. And now I want the graph of modulus of this. So whatever portion is sitting on or above the x-axis remains intact. The portion which is sitting below the x-axis, it is inverted with respect to the x-axis, right? And this is what you get. This is your final graph of the function f. Mark the values, the corresponding respective values you mark. What do you see? You see that there are exactly 3 sharp-edged points in the graph. One corresponding to 1, other corresponding to 3, and other corresponding to 5. So 1, 3, and 5 are your respective values of x for which f of x is not differentiable. So your S is a set consisting of 3 points, 1, 3, and 5. Now that I have the elements sitting inside set S sorted, let's compute summation of f of x corresponding to every x coming from set S. So when you open this summation up, it is nothing but f of 1 for x equals 1 sitting in set S plus f of 3 plus f of 5. So either from the graph you can find out these values and then hence get the sum, or from the function's definition also you can find out. Let's see what falls easy for us. So f of 1 you can see from the graph is 0, and f of 0 again you can see from the graph is 1. So this is nothing but 1. Now, f of 3 you can see from the graph is 2, but what is f of 2 is not so directly and evidently known to us. So let's compute f of 2 by the function's definition. F of 2 will be mod of 2 minus mod of 2 minus 3 and then mod close. So mod of 2 minus 3 is mod of minus 1, that is just 1. And again you get a 1, thereby giving you that f of 3 is nothing but f of 2, which is again a 1. Okay, last is f of 5. So from the graph again f of 5 is 0 and f of 0 is 1. So here also you get a 1, and therefore 3 is the final answer for this question.
For more videos and live lectures on the JEE, click on the subscribe button now.